Our robotic eyes on Mars have seen things that defy easy explanation. For decades, orbiters and rovers have sent back photographs of landscapes littered with objects that look bizarrely out of place, sparking endless debate and wonder. A face staring up from the dust, a perfect doorway carved into a cliff, even what seems like a spoon floating in the thin air. In this journey, you will see 30 of the strangest, most mind-bending discoveries ever made on the Red Planet, each a story of mystery, science, and the human imagination running wild. We will explore a rock that simply appeared out of nowhere and an atmosphere that breathes unexplained gas. The real payoff is uncovering the profound truth hidden behind these Martian illusions. What do you believe is waiting for us in the alien dust? It all began with a single, grainy photograph that would ignite a firestorm of speculation for decades. In 1976, NASA Viking 1 orbiter was mapping the surface of Mars when it captured an image of a region called Cydonia. There, amidst the rolling hills and buttes, was a formation roughly 1.5 miles across that looked unmistakably like a human face. It had what appeared to be 2 eyes, a nose, and a mouth, all staring blankly up at the cosmos. The public went wild. Headlines screamed about an ancient monument, a sphinx built by a lost Martian civilization. The idea captured the imagination of millions, suggesting we were not alone, and that evidence of another intelligent species was right there, etched into the red desert. This single image became the cornerstone of a new mythology, spawning books, documentaries, and a fervent belief that NASA was hiding the truth. Then, years later, came the sobering follow-up. With much more advanced cameras, missions like the Mars Global Surveyor returned to Cydonia. They photographed the so-called face from new angles and with crystal clarity. The high-resolution images told a different story. They revealed a very natural, heavily eroded mesa, a rocky hilltop sculpted by millions of years of wind. The haunting visage vanished, replaced by the clear lines of geology. The eyes were shadows in pits, the symmetrical features just a trick of light and shadow at a specific time of day. This is the classic example of pareidolia, our brain's hardwired habit of finding familiar patterns, especially faces, in random shapes. We see the man in the moon, a smiling face in a power outlet, and for a time, a colossal monument on Mars. The face was an illusion, but its legacy is utterly real. It taught us a crucial lesson about interpreting alien landscapes, and it unquestionably kicked off the modern era of looking at every odd rock and shadow on Mars with a mixture of scientific curiosity and boundless wonder. That initial illusion of a face set a high bar for strangeness, but sometimes the most profound discoveries are not monumental statues, but small, scattered curiosities. Years later, another rover named Opportunity was rolling across a flat plain called Meridiani Planum when its cameras revealed something utterly unexpected. The ground was not simply covered in dust and rocks. It was littered, absolutely peppered, with millions of tiny, perfect spheres. They were scattered everywhere like some cosmic game of marbles had been played across the Martian desert. In the rover's early false color images, they had a faint bluish hue, and so the scientists, with a touch of poetry, nicknamed them blueberries. They were small, most no bigger than a pea, and remarkably round. This was not a trick of light or a vague shape in a distant hill. These were tangible, physical objects that the rover could see, touch, and analyze up close. Their perfection was the puzzle. Nature rarely makes things so uniformly spherical without a very specific process at work. What geological force on a dry, dusty world could possibly create billions of near-identical little balls? The answer, when it came, was a landmark moment in planetary science. Detailed analysis revealed these blueberries were concretions, hard nodules of the mineral hematite. On Earth, such formations are often found in sedimentary rock that once sat in water. They form when mineral-rich water seeps through porous stone, and the minerals precipitate out in layers around a central nucleus, growing slowly into a sphere like a geological pearl. The presence of hematite, an iron oxide that often forms in liquid water, was the key clue. These tiny spheres were not just random rocks, they were fossilized droplets of Mars's history, physical proof that the ground opportunity was driving over had once been soaked. This was not a brief flood, but a sustained, wet environment where groundwater flowed for potentially millions of years. The blueberries of Meridiani Planum offered one of the first tangible, on-the-ground pieces of evidence that ancient Mars was not just cold and dry, but a world with a potentially habitable past. They transformed our understanding from theoretical models to a story written in stone, or rather, written in billions of tiny, iron-rich spheres scattered in the alien dust. Yet the Martian surface is not just a passive record of ancient history. It can change, and sometimes it changes in ways that leave even the scientists staring at their screens in disbelief. Years after its discovery of the blueberries, the same rover, Opportunity, was exploring the rim of a small crater called Endeavour. It took a series of panoramic photographs of the area, a routine procedure to map its surroundings. When mission controllers compared a new photo to one taken just 12 Martian days earlier, they saw something impossible. A rock had appeared out of nowhere. It was roughly the size of a jelly donut, whitish on the outside with a deep red, dimpled center. It looked utterly alien, and it was sitting right in a spot the rover's cameras had confirmed was empty just a short time before. The team named it Pinnacle Island. The immediate theories were understandably wild. Had a meteorite struck nearby and flung the rock into view? Could it be some form of Martian fungus or growth? For a brief, thrilling moment, it seemed like the red planet itself was actively offering up a new puzzle. The solution, once the rover's handlers pieced together the rover's movements, was more straightforward. As Opportunity made a tight turn, one of its wheels had clipped a partially buried rock, flipping it up and forward into the camera's field of view. The jelly donut was not delivered from the sky. It was kicked up from the dirt by the rover itself, yet the mundane origin story did not solve the entire mystery. When Opportunity examined Pinnacle Island with its instruments, the rock's composition was bizarre. It showed remarkably high levels of manganese and sulfur, elements that suggested it had formed in a wet, acidic environment very different from the surrounding bedrock. This little rock, unearthed by a chance wheel movement, was a geological outlier. Its presence hinted at a complex, layered history of water chemistry in that ancient crater rim, a story far richer than the surface dust implied. So while the rock's sudden appearance was a human-made illusion, its very existence was a genuine Martian secret, a tiny, tumbled key to understanding the planet's watery and chemically active past. The Martian landscape is a master of creating perfect, impossible geometry. In May of 2022, NASA Curiosity rover turned its mast camera toward a cliff formation known as the Greenhugh Pediment. The image it beamed back to Earth was deceptively simple, yet it ignited an instant frenzy across the internet. There, etched into the bedrock, was a clean, rectangular shadow. It looked exactly like a doorway, not a rough cave opening or a jagged crack, but a perfectly carved, man-made looking entrance, complete with a lintel above and a flat threshold below. It seemed to beckon, a secret portal leading into the heart of the Martian mountain. The imagination ran wild. Was it an ancient shelter, a tomb, evidence of intelligent design left behind by a long-vanished civilization? The scale, however, provided the first crucial dose of reality. This was no grand gateway for giants or gods. In truth, the crevice is only about a foot tall and half a foot wide. You would have to crawl on your hands and knees to squeeze through, if it even went anywhere at all. This perfect little rectangle is not a door, but a textbook example of a natural geological fracture. The bedrock on Mars is under constant, immense stress. As the planet cools and shifts, the rock layers experience strain. When that strain exceeds the rock's strength, it fractures. Often, these fractures occur along straight lines or right angles, following the natural planes of weakness within the stone. What makes this particular fracture so visually striking is likely a second act of Martian weathering. After the initial crack formed, the relentless, sandblasting wind began its work. Over eons, grains of dust carried by the thin atmosphere have scoured and widened the fracture, smoothing its edges and deepening the shadow within. The result is that crisp, rectangular void we see. It is the combined artwork of planetary stress and patient, abrasive winds. Our brains, however, refuse to see it as mere geology. We are pattern-seeking machines in an unfamiliar environment, and a perfect rectangle is one of the most human shapes imaginable. We build doors, windows, and structures with right angles. So when we see one on another world, our mind instantly categorizes it as something built, not born. This little crevice is a powerful sibling to the face of Mars, another lesson in pareidolia, but with a different flavor. Where the face was a trick of shadow on a grand scale, the doorway is a trick of geology on an intimate one. It reminds us that even the most ordinary processes on an alien world can produce features that look extraordinarily, hauntingly familiar. But the rover's cameras are not just for sweeping landscapes. Sometimes the most captivating mysteries are found by looking down at the dust right beneath its wheels. During its long trek up Mount Sharp, the Curiosity rover paused to examine a patch of rock nicknamed Garden City. There, among the dull, reddish-gray rubble, was a tiny, brilliant anomaly. It was a pale, almost white object, no larger than a penny, protruding from the stone. Its structure was astonishingly intricate, with a cluster of delicate, crystalline segments that fanned out like the petals of a tiny, fossilized flower. The Internet, of course, immediately christened it the Martian flower. The resemblance to something organic, something that might have once bloomed in an alien spring, was irresistible. Could this finally be a sign of past or even present Martian life? The reality, while not biological, is no less fascinating. This is not a flower, but a masterpiece of mineralogy. Scientists call it a diagenetic crystal cluster. Diagenetic refers to the physical and chemical changes that happen to sediment after it is first deposited. In this case, billions of years ago, this spot was likely saturated with mineral-rich water. As that water moved through the porous rock, certain salts dissolved within it, like calcium sulfate, reached a point where they could no longer stay dissolved. They began to precipitate out, crystallizing slowly in the small voids and cracks within the sediment. Over immense stretches of time, these crystals grew in intricate, branching patterns, creating the fragile, petal-like structures we see. Eventually, the surrounding, softer rock eroded away, leaving the harder, more resistant mineral formation standing in relief, like a tiny sculpture unveiled by the Martian wind. So why is this little shiny object so important? It is a chemical time capsule. The specific minerals that form these clusters are picky about their environment. They only crystallize under certain conditions, like a specific range of acidity, temperature, and salinity. By analyzing the composition and structure of this flower, scientists can read the recipe of the ancient water that created it. It tells them not just that water was there, but what that water was like. Was it briny and acidic? Was it more neutral and potentially friendlier to life as we know it? This tiny, beautiful formation is a direct record of the chemistry of a vanished Martian environment. It transforms a point on a map from a simple rocky outcrop into a site with a detailed, liquid history. The Martian flower is a paradox. It is a stark reminder that the most lifelike shapes on that barren world are often crafted by geology, not biology. Yet, in its intricate form and watery origin, it also whispers a tantalizing promise. It marks a spot where the conditions, long ago, were just complex and interesting enough to create something so deceptively familiar, a mineral bloom in the alien soil. The Martian wind is a patient sculptor capable of carving shapes so delicate they seem to defy the very logic of the world. In a different image from Curiosity, the rover captured a formation that, at a glance, looks like a discarded piece of cutlery from a giant's picnic. There, against a backdrop of dusty bedrock, appears to be a long-handled spoon, its bowl hovering impossibly in the thin air, as if caught mid-fall or held by an invisible hand. This ghost spoon became an instant sensation, a perfect symbol of Mars's surreal landscape. The truth is a brilliant lesson in light, shadow, and erosion. The spoon is not floating at all. It is a thin, narrow fin of rock, likely a harder vein of material that was more resistant to weathering than the softer stone around it. Over millions of years, the relentless wind scoured away the softer material, leaving this slender spine protruding from the ground. It is still very much attached at its handle end, anchored firmly to the bedrock. The illusion of levitation comes from the angle of the sunlight and the spoon's own shape. The bowl of the spoon is casting a shadow directly downward, and from the rover's vantage point, that shadow falls perfectly in line with the handle, hiding the point of connection. Our brains, seeing a spoon-shaped object and a shadow beneath it, instantly interpret the scene as an object resting on a surface or floating just above it. Since we cannot see the connecting stalk, we assume it is not there. This is the same reason a pencil can appear to float when you hold it against a matching background in just the right light. On Earth, we see similar, though often stouter, formations in places like Bryce Canyon. They are called hoodoos, tall, thin spires of rock topped by a harder capstone. The Martian ghost spoon is essentially a tiny, exquisitely balanced hoodoo, a testament to the fact that the same slow, artistic forces that shape our world are also at work next door. It is not evidence of a lost civilization, but of a persistent and creative natural world, one that can craft a perfect illusion of the impossible from nothing more than rock, wind, and time. While wind can carve delicate spoons, it can also shape rocks with a more unsettling familiarity. Another image from the Curiosity rover shows a rock that, at first glance, seems to tell a morbid story. Lying in the dust is an object with a long, straight shaft and a rounded, bulbous end. The resemblance to a fossilized human thigh bone is so striking it sparked a wave of headlines about discovering evidence of ancient Martian life, or perhaps even giants. A side-by-side comparison with a real fossil femur shows an eerie similarity in the basic silhouette, but this is where the story diverges sharply from science fiction. The science is unequivocal. Mars, for its entire history as we understand it, has lacked the fundamental biological processes necessary to create large, complex animal life. There is no evidence of an ecosystem that could support large vertebrates with the food chains, oxygen levels, and evolutionary pressures needed to produce something with a skeleton like ours. Furthermore, even if such an impossible creature had existed, the Martian environment would have utterly destroyed its remains. The planet's surface is bombarded by intense ultraviolet radiation and cosmic rays, unshielded by a thick magnetic field. Bone and organic material would be broken down and sterilized long before fossilization could ever occur. So what are we really looking at? This is another masterful work of erosion, but of a different kind. The thigh bone rock is likely a type of ventifact, a stone shaped solely by the wind. Over eons, sandblasting particles have scoured and abraded the rock, wearing away softer material and leaving behind a harder, more resistant core. The process is not random. Wind direction, the rock's original composition, and tiny fractures all guide the sculpting. The result can be a strangely streamlined shape, one that our pattern-seeking brains instantly lock onto and categorize. We see a femur because our minds are flooded with references from our own world. NASA planetary geologists have been clear and consistent on this point. The object is a curiously shaped rock, a geological oddity, not a biological one. It is a testament to the power of wind as a sculptor. capable of creating forms that mimic life so perfectly they can fool us from millions of miles away. This rock, like the ghost spoon, is a reminder that Mars needs no giants to create giant mysteries. Its ordinary forces are extraordinary enough to craft illusions that challenge our perception and fuel our deepest curiosities about the red planet's silent, stony past. Perhaps the most primal of all Martian illusions is not a face or a fossil, but a creature caught in the act. In July of 2015, a raw black and white image from the Curiosity rover's navigation camera swept across the internet. It showed a rocky recess, a shallow alcove in the shadow of a large stone. Within that dark patch, a cluster of pixels seemed to resolve into something horrifyingly familiar. There appeared to be a crab-like form with multiple spindly legs splayed out and a rounded, armored body, as if some alien crustacean were crouching in the gloom, waiting. Others saw not a crab but a scuttling spider, its silhouette clear against the lighter rock behind it. The crab monster of Mars was born, and for a brief, thrilling moment, it felt like we had finally glimpsed something alive and moving on that dead world. The raw, unprocessed nature of the image only fueled the mystery. This was not a polished color panorama from the rover's main science camera. It was a grainy, low-resolution navigation shot designed purely to help the rover's drivers on Earth plan its next move. The pixelation was severe, and in the high contrast between deep shadow and sunlit rock, our brains desperately tried to make sense of the noisy, ambiguous shapes. They found a pattern, and that pattern was a potential predator. This is shadow pareidolia at its most instinctive. For millions of years, human survival depended on the ability to spot threats in our peripheral vision, to see the tiger in the tall grass before it saw us. Our visual processing system is hardwired for this. It is far safer for our ancestors to mistakenly see a stick as a snake and jump than to mistake a snake for a stick and die. This hyper-vigilant pattern recognition does not switch off when we look at pictures from another planet. In fact, it intensifies. We are staring into an alien environment, a place we know is profoundly strange, and our minds are on high alert, subconsciously searching for anything that fits a known category, especially the category of living thing. When Curiosity's team later pointed the rover's high-resolution mastcam at the same rocky alcove, the monster vanished. The crab-like shape dissolved into a jumble of completely ordinary rocks and sharp shadows. There were no legs, no carapace, just the random, jagged geology of Mars. The high-resolution image provided too much visual information, filling in the gaps that our imaginations had so eagerly populated. The persistence of these creature sightings, from crabs to rats to lizards, speaks to something deeper than just curiosity. It reveals our profound longing for company in the cosmos and a deep-seated evolutionary caution about the unknown. Every fuzzy shadow that resolves into a monster is a testament to a brain built for a dangerous Earth, now gazing out across the silent, rocky plains of Mars, forever seeing ghosts in the machine's grainy gaze. From fuzzy monsters in the shadows, we shift our gaze upward to a scale so vast it reveals a different kind of Martian magic. Orbiting high above the planet's southern hemisphere, the Mars Reconnaissance Orbiter once captured an image that seemed to bridge science and science fiction. There, sprawled across the floor of the immense Hellas Basin, was a dune field shaped with uncanny precision. It was not a face or a fossil, but a symbol. The sweeping curves and sharp central point formed a near-perfect replica of the iconic Starfleet insignia from Star Trek. This was not a tiny rock or a trick of shadow. This was a sprawling geographical feature, a testament to the wind's artistry on a planetary canvas. The formation is what scientists call a Barchan dune field. Each individual dune is a crescent-shaped mound of sand with two horns pointing downwind. These dunes are not static. They are born from a consistent, one-directional wind that piles sand into these distinctive forms, and they actually move, marching slowly across the landscape like sandy caterpillars. In this specific region of Hellas, the largest impact crater on Mars, the wind patterns have aligned in a way that arranged countless Barchan dunes into a collective shape that mirrors our pop culture icon. The central chevron is likely a larger dune or series of dunes with the sweeping wings formed by the fanned-out horns of the surrounding crescents. It is a magnificent coincidence of fluid dynamics and geometry, written in sand across a distance of miles. What makes this discovery so special is the reaction it sparked. NASA scientists did not dismiss it as a silly optical illusion. They embraced it. The image was officially released by the University of Arizona's high-rise camera team with a playful caption acknowledging the similarity. This highlights a beautiful truth about exploration. Science is driven by rigorous data and sober analysis, but it is conducted by people who grew up watching starships explore strange new worlds on their television screens. Finding a piece of that fictional universe etched into the real sands of Mars is a moment of pure, joyful connection. It is a reminder that discovery is not just about profound truths, it is also about wonder and shared culture. That sprawling insignia in the desert is a happy accident, a cosmic wink from the wind-scoured plains of Mars to the dreamers on Earth who have always looked to the stars and imagined what might be waiting. The wind's grand sand art is one thing, but our search for familiar shapes often shrinks down to a human scale, seeking not just symbols but sentinels. Among the very first images to spark the idea of a populated Mars came not from a modern rover, but from the same Viking orbiters that captured the famous face. In another photograph of the Cydonia region, a different anomaly was singled out. When a small section of the image was blown up and enhanced, a blurry, pixelated form seemed to emerge. Against the backdrop of a large, shadowed boulder, there appeared to be a small, seated figure. It had a rounded head, what looked like shoulders, and even suggestions of outstretched arms, as if this tiny being were sitting on the rock watching the alien sky. Conspiracy theorists and tabloid newspapers ran with it, dubbing it the woman on Mars or an alien statue, presenting it as clear proof that someone or something was waiting there. The story took on a life of its own in the nascent days of the internet, becoming a foundational piece of Martian mystery lore, a cousin to the giant face just over the horizon. The reality, once the full context of the original Viking image is examined, is almost comically mundane. The so-called woman is not a statue, nor is it even a separate human-sized object. It is a small, dark rock, perhaps no larger than a football, perched atop a much larger, lighter-colored boulder. The Viking orbiter's camera, while revolutionary for its time, had limited resolution. When a tiny fraction of that already grainy image is isolated and enlarged to an extreme degree, the individual pixels that make up the rock and its shadow begin to blur together. Our brains, desperate to resolve this fuzzy, abstract block of pixels, instinctively connect the dots. The random pattern of light and dark is interpreted as the contours of a head, a torso, and limbs. It is a perfect storm of pareidolia, amplified by poor image quality and aggressive digital zoom. This phenomenon is not unique to Mars. You can see it in the world around you. Take a low-resolution photograph of a clump of moss on a tree stump. Zoom in until it's a blurry mess, and with a little imagination, you might see a face or an animal. The early internet forums that championed the woman on Mars were doing exactly that, but with the thrilling backdrop of another planet. They were not necessarily being dishonest, but they were being led by a powerful psychological impulse, one that was supercharged by the tantalizing possibility of discovery. The tale of the tiny seated figure teaches us a crucial lesson about evidence and scale. It highlights how, in our excitement, we can misinterpret the size and nature of objects in an alien landscape, and how a story, once launched into the cultural atmosphere, can orbit for decades long after its original premise has been dissolved by clearer data. The tiny, seated figure was a product of grainy pixels, but sometimes the desire to see life is so strong we find it in the pebbles at our feet. During its exploration of the Gale crater, NASA Curiosity rover sent back a panorama where one small, dark object in the foreground stood out. Perched on a bright rock, its silhouette was unmistakable. It had a rounded body, a tapered snout, and even what looked like two little ears or a hunched back. The internet pounced, instantly christening it the Martian rat. Here was a creature, it seemed, caught mid-scurry, frozen in the act of living its tiny life on the red planet. This is mouse-sized pareidolia in its purest form, a testament to how our pattern recognition zooms in on the smallest details, searching for anything that moves, breathes, or resembles the familiar fauna of our own world. The emotional pull is powerful, born from a deep and simple hope. Finding microbial fossils would be a monumental scientific triumph, but it is abstract. Spotting a rat, a lizard, or a crab feels immediate. It suggests a Mars that is not just a museum of ancient chemistry, but a place with a present, a place where something is alive right now, sharing the cosmos with us. The scale, however, shatters the illusion. This Martian rat is not a creature at all, but a very small, wind-sculpted rock, likely no larger than an actual mouse. Its evocative shape is the handiwork of eons of gentle sandblasting, carving a random pebble into a form that perfectly trips our animal spotting instincts. Even NASA scientists got in on the fun, addressing the viral sensation with their characteristic blend of data and dry wit. A spokesperson noted that while the object's resemblance to a rodent was amusing, the chances of finding a rat on Mars were, quote, vanishingly small. They gently guided the public excitement back toward the geological marvel it truly represented. This moment captures a beautiful tension in our exploration. There is the rigorous, patient work of science, methodically analyzing soil samples and atmospheric data. And then there is the instantaneous human reaction to a photograph, the leap of the heart at the thought of a companion in the vastness. The Martian rat, a tiny speck of stone, became a global celebrity not for what it was, but for what it represented in all of us. That enduring, hopeful gaze into the alien dust, forever looking for a sign that we are not alone. The desire to see life can shrink our focus to a single pebble, but Mars also operates on a scale of breathtaking grandeur. High on the slopes of Mount Sharp, the Curiosity rover has gazed out across landscapes that look less like geology and more like the hide of a colossal, petrified beast. The ground is covered in what scientists call dragon-scale terrain. Vast fields of stone are fractured into thousands of interlocking pentagonal plates, each one ringed by raised ridges. The pattern is mesmerizing, a natural mosaic of reptilian scales stretching toward the horizon, shimmering in the Martian sun. This is no small illusion or trick of shadow. This is a sprawling, physical texture etched into the bedrock itself, a testament to a violent and cyclical ancient climate. The secret to these scales lies in a story of water, chemistry, and relentless drying. Billions of years ago, this location was likely the floor of a vast lake or a repeatedly flooded plain. Mud, rich with minerals, would settle and saturate with water. Then the environment would shift. The water would retreat, either evaporating into the thin air or seeping down into the ground, and the saturated mud would begin to dry out. As it lost moisture, it would contract and crack, much like the cracked bed of a dried-up pond on Earth. But here, the process was amplified and complex. Scientists believe a specific ingredient was at work, a layer of sulfate salts. As the muddy water evaporated, these dissolved salts would have concentrated and crystallized on the surface, forming a hard, brittle crust atop the shrinking mud below. Think of a layer of hardened plaster on top of wet clay. As the clay dries and shrinks, the rigid plaster cannot flex with it. Instead, it fractures. The stress creates a network of cracks that propagate downward, dividing the material beneath into distinct polygons. Over immense stretches of time, wind erosion then scours away the softer material in the cracks, leaving the harder, raised edges of each polygonal plate standing in relief. The result is this field of sculpted scales. Each one is a fossilized record of a single moment of drought in an ancient wet cycle. By studying the size and shape of these polygons, geologists can read the environmental conditions. Smaller polygons suggest rapid drying, perhaps in a warmer or windier climate. Larger ones point to a slower, more gradual loss of moisture. The dragon scale terrain is not just a beautiful oddity. It is a direct physical diary of Mars' climatic pulse, a rhythm of wet and dry periods that may have persisted for millions of years, creating a landscape that feels both alien and eerily familiar, like the skin of a story waiting to be read. The dragon scales tell a story of ancient mud and drying cycles, but other formations on Mars seem to whisper of life on a much larger scale. Among the most persistent visual puzzles are objects that, from the rover's distant perspective, look like the scattered remains of giants. In one celebrated image, a long, slender, and segmented object lies half buried in the dust, its silhouette hauntingly similar to a whale's vertebrae or a massive fossilized spine. In another, a smooth, cylindrical form stretches across the ground, resembling nothing so much as a petrified log, complete with what seems like a tapered end. The first instinct is to gasp. Could these be the bones of a lost Martian leviathan, or the trunks of ancient trees that once drank from vanished rivers? The scale, however, provides instant, sobering context. These are not the size of buildings or even buses. The so-called whalebone is a rock perhaps a foot or two long. The log is a similarly modest cylinder. They are simply rocks viewed from dozens of feet away through a robotic lens that flattens perspective. Yet their power to captivate is undeniable because they tap directly into our deepest narrative for Mars, the idea of a world not just wet but truly alive, a planet that once hosted ecosystems with large flora and fauna. We yearn for that story to be true. The geological reality, while not biological, is no less fascinating. These elongated, segmented, and cylindrical shapes are masterpieces of sedimentary erosion. The bedrock in these areas was laid down in layers like a cosmic layer cake in those ancient wet environments. Different layers have different compositions. Some are soft mudstone, others are harder sandstone or deposits of resistant minerals. When the wind, acting like cosmic sandpaper, scours this landscape, it eats away the softer material faster. What remains are the more durable layers which can erode into long, linear ridges. If those resistant layers are also fractured by stress into blocks, you can get a series of segmented, bone-like protrusions. The smooth, log-like cylinder could be a concretion, similar to the blueberries but formed in a different shape within a crack or a burrow, later exposed as the surrounding rock weathered away. It might also be what geologists call a ridge-forming vein, where mineral-rich water once filled a fracture, depositing a harder material that now stands proud as everything else erodes. True macroscopic fossils, if they ever existed on Mars, would almost certainly look nothing like this. On Earth, large bone fossils are rarely found in perfect, articulated isolation on the surface. They are typically buried and discovered through careful excavation. They also have a specific porous microstructure visible under a microscope. A petrified log would show clear cellular wood grain and growth rings. The objects on Mars lack these telltale textures when examined closely. They are monolithic and stony. These phantom bones and logs are thus a double revelation. They are stunning examples of how non-living processes can craft the perfect illusion of life playing on our hopes. But they are also genuine records of a dynamic, watery, and chemically active past, a past complex enough to create landscapes that continually, heartbreakingly, remind us of the living world we left behind. While our eyes are drawn to shapes in the rock, some of Mars's greatest mysteries are completely invisible. They linger in the thin, cold air, waiting for a sensitive instrument to catch their fleeting signature. For years, NASA Curiosity rover has been doing just that, sniffing the Martian atmosphere inside Gale crater. and what it has found has sent a consistent, puzzling tremor through the scientific community. On multiple occasions, its onboard laboratory has detected sudden, sharp spikes in the concentration of methane gas. These are not steady background levels. The methane appears unpredictably, surges to levels up to 10 times the normal trace amounts, and then vanishes just as quickly, as if the planet itself were taking a brief, mysterious breath. This discovery is electrifying because of what methane represents. On our own planet, the vast majority of atmospheric methane has a biological origin. It is belched by cows, released by decomposing plant matter in wetlands, and most intriguingly, produced by vast communities of subsurface microbes called methanogens. These tiny life forms do not need oxygen. They thrive in dark, watery environments underground, metabolizing simple chemicals and releasing methane as a waste product. So, when we detect methane on another world, the immediate, thrilling question is unavoidable. Are we smelling the exhaust of alien life? Yet biology is not the only chef that can cook up methane. There is a geological recipe too. A process called serpentinization occurs when certain iron-rich rocks, like olivine, come into contact with water in a chemical reaction that produces hydrogen. That hydrogen can then react with carbon dioxide in the presence of a mineral catalyst, creating methane. This is a purely abiotic process requiring no life whatsoever. It means a geologically active Mars with liquid water still interacting with rock deep below the frozen surface could also be the source. This sets the stage for one of the most intense detective stories in modern planetary science. Curiosity's data presents a maddening puzzle. The spikes are local, transient, and seem to waft through the crater on the breeze. Where is the source? Is it a nearby, hidden seep, or is the gas being released from a network of cracks and carried from afar? The ExoMars Trace Gas Orbiter, a European spacecraft designed specifically to map atmospheric gases from high above, has so far failed to detect these same dramatic spikes globally, adding another layer of confusion. This suggests the methane is being produced or released in very localized, ephemeral patches, and then quickly destroyed by the harsh ultraviolet radiation at the surface. The scientific debate is fierce and fundamental. The biological hypothesis whispers of a stunning possibility that simple, resilient microbial communities could be clinging to existence in aquifers deep below the Martian regolith, their faint metabolic signature occasionally bubbling up to the surface. The geological hypothesis paints a picture of a planet that is still chemically alive, its interior water and rock slowly interacting in ways that mimic but do not replicate the signs of life. Each new data point from Curiosity is a clue scrutinized by teams around the world. This strange, invisible find is perhaps the most profound on our list. It asks the ultimate question not with a shape in a rock, but with a whiff of gas on the wind, a spectral hint that the red planet's greatest secret might be hiding just beneath our feet. Methane's invisible whisper is a puzzle for instruments, but some Martian mysteries arrive as a flash of light directly to the eye. During its long mission, the Curiosity rover has occasionally transmitted a raw image that stops scrolling scientists in their tracks. The picture shows the familiar, sun-bleached horizon of Gale Crater, a rolling line of ancient rock and dust, but there, in the distance, is a brilliant, stark white pinprick. It looks like a single, impossibly bright star shining in the Martian daytime, or worse, like a distant artificial lamp switched on in the gloom. In one famous pair of images taken just a week apart, the bright spot appears in the first frame and is completely gone in the second. The immediate, thrilling interpretation is obvious: something out there is producing light. The mind races to possibilities, from reflective structures to something far more speculative. NASA explanation, however, steers us firmly from the speculative to the subatomic. These are almost certainly cosmic ray hits. our solar system is flooded with high-energy particles, protons, and atomic nuclei racing at nearly the speed of light from distant supernova and other violent cosmic events. Mars, lacking a strong global magnetic field and a thick atmosphere, has little protection from this barrage. When one of these tiny, invisible bullets strikes the light-sensitive detector inside the rover's camera, it deposits a burst of energy. The camera's computer reads this sudden spike as an intense point of light, painting a single, dazzling white pixel or a small cluster of them onto the image. It is a digital scar from a particle that traveled across the galaxy. The other plausible explanation is more mundane but equally fascinating: a sun glint. On a world where everything is covered in a fine, reddish dust, a rare outcropping of bare, reflective rock, perhaps a crystal face of quartz or a smooth face of volcanic glass, could act like a tiny, angled mirror. If the sun, the rover, and that specific reflective surface align in a perfect, fleeting geometry, the camera would catch a spectacular gleam, a natural lighthouse flash from the crater rim. Both explanations highlight the profound technical challenges of interplanetary photography. Every image we receive is a miracle of data transmission, but it is also raw data, susceptible to noise and artifact. Scientists working with these pictures are like detectives examining a photograph for clues, but they must first distinguish the real scene from flaws in the film itself. In the early days of Martian exploration, such an artifact might have remained a permanent, unsolved mystery. Today, mission teams have a robust toolkit for solving them. They take multiple images of the same area. A cosmic ray hit, being random, will appear in one frame and vanish in the next. A sun glint might persist across several images as the sun moves. They also have a deep understanding of their camera's behavior, knowing how it responds to different stimuli. So, while our hearts might leap at the sight of a distant beacon, the science tells a story that is, in its own way, just as incredible. It is a story of a planet bathed in invisible, high-energy radiation, of landscapes that can still produce a blinding flash from a sunbeam, and of the meticulous work required to listen to a world's true story over the constant static of the cosmos. A perfect sphere rests in the Martian dust, an orb so round it seems to have rolled off a cosmic assembly line. In the jagged, broken landscape of Gale Crater, the Curiosity rover found this singular stone, its smooth curvature a stark contrast to every fractured rock around it. It looks like a cannonball, a ball bearing, something crafted by a tool and placed deliberately on the ground. Yet this flawless form is not a product of intelligence but of patient, precise chemistry. It is another concretion, a cousin to the tiny blueberries, but formed under conditions that allowed it to achieve this remarkable symmetry. The process begins, once again, with liquid water saturating porous rock deep in Mars's ancient past. Dissolved minerals like iron oxide or calcium carbonate circulate in that groundwater. When the chemical conditions are just right, these minerals begin to precipitate out of solution, but they do not simply form a random crust. They gather around a central nucleus, a tiny sand grain, a fleck of ash, and crystallize outward in all directions equally. Imagine a pearl growing in an oyster, layer upon microscopic layer, but happening within the pores of a sandstone instead of a shell. Given enough time and stable conditions, this uniform growth in 3 dimensions produces a perfect sphere. On Earth, we see this phenomenon in places like the Utah Desert, where weathering has liberated countless iron oxide spheres known as Moqui marbles from the surrounding sandstone. They litter the ground like the discarded toys of giants. The Martian orb is a solitary example of the same exquisite process, a geological artifact proving that the ancient groundwater there was not just present but chemically active for a very long time. Its perfection is a signature of stability. For a sphere to form this way, the chemical environment must have been consistent, the water flow gentle, and the nucleus undisturbed for perhaps millions of years. So while it triggers that familiar feeling of seeing something manufactured, This stone is actually a more profound discovery. It is a natural masterpiece, a frozen bubble of mineral growth that records a chapter of Martian history where conditions were not just wet but remarkably calm and consistent. In a landscape of violent impacts and howling winds, this silent sphere speaks of a deep, quiet, and patient past. A perfect sphere hints at quiet, subterranean chemistry, but some stones tell a far more dynamic story. In a region of Gale crater named Hotter, the Curiosity rover came upon a sight that silenced any lingering debate about Mars's watery past. Jutting from the ground was a slab of conglomerate rock, and embedded within it were hundreds of pebbles. But these were not the jagged, broken fragments of a meteorite impact or a volcanic blast. They were smooth, they were rounded. Many were almost perfectly oval, their edges worn soft by a force that only exists in one environment. This was a fossilized riverbed. Each of those pebbles was a silent witness to a vanished torrent. On Earth, you can find identical stones in any creek bed or along a riverbank. Their shape is a direct record of a journey. When a rock falls into flowing water, it is not simply carried. It is rolled, tumbled, and bounced along the bottom, colliding with other stones and scraping against the sediment. With every mile, the sharp corners are knocked off. With every year, the rough faces are ground down. The process, called abrasion, transforms a jagged fragment into a smooth, rounded cobble. The very existence of these pebbles proved that water did not just seep or pool on Mars. It flowed with purpose and power, but the scientists did not stop at the simple fact of the river. They became detectives, using the stones themselves to reconstruct the scene. By measuring the size of the pebbles, some as large as golf balls, they could estimate the strength of the current that carried them. Larger, heavier pebbles require faster, deeper water to move. The calculations painted a startling picture. This was not a timid trickle. The ancient river that ran through Hotter was likely ankle to waist deep, and it flowed with a steady, persistent speed, maybe a couple of feet per second. That is a vigorous, continuous stream, the kind that could carve channels into bedrock and sustain a complex landscape. It meant the water was not a fleeting anomaly. It persisted long enough to smooth these stones over a distance of many miles, suggesting a climate stable enough to support a network of rivers, perhaps even feeding into a long-lived lake in the crater below. These ordinary-looking pebbles are among the most extraordinary finds on Mars. They are not a strange illusion or a trick of the light. They are physical, tangible relics of a world that once sounded like Earth. If you could have stood on that riverbank billions of years ago, you would have heard the rush of water and the clatter of stones rolling downstream, a familiar chorus on an alien world. The rounded river stones of Hotter speak of a planet in motion, but other formations reveal a world that grew still, its secrets crystallizing in perfect silence. High on the slopes of Mount Sharp, the Curiosity rover encountered a patch of bedrock that seemed to glitter with an otherworldly treasure. Scientists named the site Garden City, and it was a fitting title. The rock face was not smooth or fractured. Instead, it was studded, absolutely peppered with dozens of brilliant, protruding formations. They stood out starkly against the dull, reddish stone like a cluster of pale, thorny flowers or a miniature city of crystalline spires. These are not random pebbles or wind-carved oddities. Each one is a complex, branching cluster of minerals, a delicate sculpture formed deep within the Martian crust and later unveiled by the patient hand of erosion. These intricate structures are what geologists call crystal clusters or crystal aggregates. Their story begins with fractures, billions of years ago, when this rock was still buried and the area was likely saturated with groundwater. The bedrock developed a network of fine cracks. Mineral-rich water, heated by the planet's interior or simply circulating through the porous layers, began to flow through these subterranean passageways. As the water moved, it carried dissolved salts, most likely calcium sulfate, a mineral we know as gypsum. When the chemical conditions changed, perhaps from a shift in temperature or pressure, or simply as the water evaporated, those dissolved minerals could no longer stay in solution. They began to precipitate out, crystallizing directly onto the walls of the tiny fractures. Think of it like the hard, mineral crust that forms inside an old pipe. Over immense stretches of time, layer upon microscopic layer of these crystals grew, filling the cracks from the inside out. They did not grow as a solid plug, but often in intricate, branching patterns that maximized their surface area, creating those thorny, petal-like shapes we see. The real magic, however, happened much later. After the crystals had fully formed, the environment above them changed dramatically. Mars lost its surface water and its thick atmosphere. The relentless wind took over as the primary artist. The softer bedrock surrounding these hardened mineral veins was far more susceptible to erosion. Grain by grain, the wind scoured away the matrix rock, the host stone that once encased the crystals. But the crystal veins, being much harder and more resistant, could fight back. They withstood the sandblasting far better. The result is what geologists call differential erosion. The soft material was stripped away, leaving the harder material standing in proud relief. The crystal clusters at Garden City are not sitting on top of the rock. They are growing out of it because they are the rock's own skeleton being revealed. They are the durable fossilized plumbing of an ancient groundwater system, now exposed to the Martian sky. Their composition, likely calcium sulfate, is another crucial clue. This mineral readily forms in the presence of liquid water, and its specific crystal shapes can tell scientists about the chemistry, temperature, and even the flow rate of the water that deposited it. Each delicate, thorny spire is therefore a data point, a physical record of the conditions within those long-vanished underground streams. In their stark, beautiful forms, they offer a glimpse into a hidden, watery world that once thrived beneath the desolate surface, a garden of stone blooming from the memory of ancient springs. Even the most basic shadows can become monsters in our minds. Among the thousands of images beamed back from the surface, one particular photograph from the Opportunity rover captured a moment of pure, stark silhouette. On the rim of a crater, a long, thin, vertical shadow stretches across the dust. At its top, the shadow widens into a rounded, bulbous shape, and from this head, a second, shorter protrusion angles out like an arm. The composition is startling. It looks exactly like a lone, stick-figure humanoid caught mid-stride as it walks across the alien plane. The shadow seems to possess a head, a torso, and one distinct limb, a solitary wanderer on the endless red horizon. For a brief, viral moment, this was it. This was the evidence so many had waited for, proof not just of ancient life, but of an intelligent presence walking Mars today. The speculation exploded, with theories ranging from a surviving native to a visiting extraterrestrial scout, its elongated form perfectly matching our classic image of a gray alien. The reality, as always, lies in the simple physics of light and a rock's unremarkable shape. When scientists and image analysts located the object casting this iconic shadow, the magic dissolved. The figure was not a being, but a small, jagged stone no more than a few inches tall, perched on a slight rise. The Martian sun was low in the sky, perhaps near sunrise or sunset, casting long, dramatic shadows across the landscape. This low angle is the key to the illusion. Just as your own shadow becomes a giant at dusk, the sun's raking light stretched the rock's irregular profile into a tall, distorted phantom on the ground. The rock's own lumpy, asymmetrical shape, with one protruding nub, created the apparent head and arm. There was no walking figure, only a stationary pebble and the sun's relentless geometry. Yet the intensity of the reaction reveals something profound about us, not Mars. This is pareidolia fused with a deep narrative longing. We are a social species, storytellers by nature. When we look into the cosmic void, we do not just seek chemistry or geology, we seek company. We crave a reflection. The silhouette of a walking figure is the ultimate mirror. It suggests not just life, but life like us with purpose and motion. It transforms a dead world into a stage, a place where a story is happening right now. This simple shadow fulfilled that craving perfectly, offering a narrative anyone could understand, a visitor, an explorer, a neighbor. Its power was not in its reality, but in its symbolism, a blank screen onto which we could project our oldest questions and our most persistent hopes about who or what might be waiting in the silent deserts next door. The human mind can find meaning in the shadows, but sometimes the strangest objects are not illusions at all. They are simply ours. In a stark close-up from the Curiosity rover, the Martian regolith holds a startling artifact. Resting on the ruddy soil is a small, thin, and unnervingly angular object. It shines with a bright, metallic luster, its edges sharp and precise against the chaotic backdrop of dust and pebbles. It looks for all the world like a discarded machine part, a screw or a bracket that fell from some unknown assembly. The immediate, thrilling leap is to wonder what ancient machinery it could have come from. Yet the truth brings the mystery crashing back to Earth. This is not a relic of Mars. It is a piece of the rover itself, or more accurately, a piece of the system that delivered it. Analysis strongly suggests it is a shredded fragment from the spacecraft's dramatic descent, perhaps a piece of the heat shield that shattered during entry, or a frayed strand of the supersonic parachute cord. It is human-made debris carried across hundreds of millions of miles and deposited on this alien shore. The discovery serves as a profound and necessary reality check. Finding a manufactured object on another world is only strange if we forget that we have become manufacturers there. Since the 1970s, we have been sending our robotic emissaries to Mars, and each one leaves a trace. There are defunct landers, silent rovers, scattered heat shield fragments, and even the crashed remains of landing platforms. They are the first archaeology of another planet, and it is an archaeology of ourselves. This shiny sliver of material forces us to confront the concept of planetary protection. Every mission is meticulously sterilized to prevent Earth microbes from hitchhiking to Mars, but we cannot sterilize the violent physics of arrival. A heat shield must ablate and break apart, a parachute must shred and fall away. We are inevitably contaminating the very environment we seek to study in its pristine state. So this strange metal object is a dual symbol. It is a testament to our incredible engineering, a piece of home that survived a fiery journey to another world. But it is also a silent warning, a reminder that as we search for signs of life, we must be ever vigilant to distinguish the signals we send from the signals we hope to find. The red planet is no longer a purely alien world. It now bears the faint, scattered fingerprints of humanity. Our own debris now litters the red planet, but some of its most convincing illusions are carved from the planet's own bones. Among the scattered rubble of Gale Crater, the Curiosity rover once focused its camera on a single, arresting stone. It was a near-perfect pyramid. The rock had sharply defined, triangular faces that met at a crisp point, sitting on the dusty plain like a miniature monument, a scale model of Giza left behind in the Martian wilderness. The symmetry was so precise, the geometry so clean, that it seemed impossible for it to be anything but artificial. The immediate, powerful narrative wrote itself. Was this a cornerstone from a fallen temple, a marker left by an ancient civilization, or perhaps even a cosmic signpost? The reality, as with so many Martian mysteries, comes down to a simple matter of scale. This is not a colossal structure. The pyramid rock is tiny, roughly the size of a football. It is not a building, but a pebble, a singular piece of geology that happens to have been sculpted into a breathtakingly geometric form. This is the work of a specific and patient artist, the Martian wind. Geologists call such a stone a ventifact, from the Latin for wind-made. Its creation is a slow, meticulous process. For millions of years, prevailing winds have carried fine, abrasive sand across the surface. When such a rock lies in the path of a consistent, sand-laden breeze, it becomes a natural sandblaster's project. The wind does not erode the rock evenly. Instead, it attacks the surfaces facing the wind most directly. The sand grains chip away microscopic fragments, gradually wearing down the rock's faces into flat, smooth plains. If the wind direction is remarkably steady over eons, or if the rock occasionally shifts to present new facets to the breeze, the result can be a multi-sided pyramidal shape. The process is akin to a gem cutter, but where the tool is an invisible river of dust and the timescale is geologic. On Earth, we find identical formations in our own most arid deserts. In places like the Atacama Desert in Chile or the Namib Desert in Africa, ventifacts with similarly perfect facets and sharp edges are common, known locally as Dracanter or three-edged stones. They are natural sculptures, proof of the wind's directional persistence. So, the Martian pyramid is not a sign of intelligence, but a signature of environment. Its perfect shape is a wind vane fossilized in stone, a record of the ancient atmospheric currents that have swept across Gale Crater for ages. It tells us that the winds there have been remarkably consistent in their direction for an almost unimaginable length of time. This small, football-sized rock is therefore a masterpiece twice over. It is a stunning natural sculpture that tricks the human eye with its artificial perfection. And it is a scientific instrument, a silent anemometer that has measured the Martian climate for millions of years, its facets pointing like an arrow to the secrets of the planet's enduring weather. Even a casual glance at the Martian soil can conjure a menagerie. Among the countless stones imaged by the Curiosity rover, one particular formation earned the playful nickname of the Iguana Rock. From the rover's initial vantage point, the resemblance was just enough to make you look twice. There was a distinct, rounded protrusion that could be seen as a head, a long, low body with a textured ridge running down its back like a spine, and even a few smaller outcrops beneath that suggested stubby legs, as if the creature were crouching in the dust, basking under the weak Martian sun. It was another perfect example of our brain's pattern-matching software, which is always scanning for familiar forms, especially the shapes of other living things. This harmless, fun illusion triggers the same mental shortcut that makes us see animals in clouds. Our visual cortex takes a few ambiguous lines and shadows and instantly fills in the blanks, presenting us with a complete, recognizable image of a lizard to explain the random arrangement of stone. The magic, however, is entirely dependent on a single, frozen perspective. When Curiosity moved on, capturing the Iguana Rock from a different angle, the spell was broken. The next photograph revealed the formation in its full, unremarkable truth. What had been a distinct head was now clearly just the end of a small, tilted slab. The textured back was simply the natural layering of sedimentary rock. The legs dissolved into unrelated pebbles scattered nearby. The creature vanished, leaving behind nothing but geology. This is the core lesson of so many Martian mysteries, repeated in a light-hearted key. Our first impressions on an alien world are framed by a single snapshot, a solitary point of view. Without the ability to walk around the object, to see it in 3 dimensions and in changing light, our brains are forced to make a best guess with limited data. And our best guess is always rooted in the biology and culture of Earth. The Iguana Rock is a gentle reminder that the Red Planet is a master of stagecraft, offering a compelling performance from one seat in the house, while the reality backstage is always more ordinary and often more scientifically interesting. It is not a failed discovery, but a successful demonstration of how easily we can be fooled, and how crucial movement, new angles, and patient observation are to seeing Mars for what it truly is. A curious, hollowed-out rock sits alone on the plain, its shape whispering of something more than geology. This formation, spotted by the Curiosity rover, looks uncannily like an ancient helmet or a weathered skullcap discarded by some long-vanished warrior. It possesses a rounded dome, a distinct brim, and a hollowed-out interior, as if it were designed to fit over a head. The resemblance to human armor is so strong it feels intentional, a relic waiting to be picked up and examined. Yet this is no artifact of war, but a masterpiece of volcanic violence and patient erosion. The rock is almost certainly a chunk of vesicular basalt. That name, vesicular, comes from the Latin for little bladder, and it tells the entire story. Billions of years ago, this stone was not a stone at all, but a frothing, molten lava flow on the surface of Mars. As the lava cooled and solidified, gases trapped within it, like carbon dioxide and water vapor, tried to escape. They formed bubbles, frozen in time as the rock hardened around them. The result is a rock filled with a Swiss cheese-like network of holes and cavities, a literal fossil of its own explosive birth. When such a rock is subjected to the Martian elements, the erosion process becomes selective. The wind-driven sand scours away at the entire surface, but it works faster on the weaker areas, the thin walls between those ancient gas bubbles. Over eons, this can hollow out entire sections, leaving behind a skeletal, sculpted form. The helmet shape likely emerged because one side of the rock was more exposed to the prevailing wind, or perhaps it had a harder, less vesicular crust that acted as a protective cap while the softer interior was excavated away. Alternatively, it could be a case of a harder rock encasing a softer core where the core erodes completely, leaving only the resistant shell behind. This object, in all its strange familiarity, taps into a deep human instinct. For our entire history, we have been a species of tool makers and artifact creators. We see a shaped stone and we instinctively ask who made this and for what purpose. This mental template is so strong that we apply it even when gazing at landscapes utterly devoid of human history. On Earth, a naturally rounded stone might be mistaken for a primitive hand axe. On Mars, a wind-carved vesicular basalt becomes a helmet. It is a profound cognitive leap, one that reveals less about Mars and more about us. We are pattern-seeking creatures, yes, but we are also storytelling creatures. We do not just see a shape, we imbue it with a narrative. This hollow rock becomes a character in a lost epic, a tangible clue to a saga of conflict and survival that never happened. It is a silent monument to the power of human imagination, our relentless drive to populate the emptiness with meaning, even when the only sculptor is the silent, patient wind. The Cydonia region is a landscape that keeps on giving to the imagination. Not far from the site of the infamous face, orbital cameras captured another formation that seemed to whisper of ancient grandeur. To some, this particular cluster of mesas and shadows did not resemble a human face, but something even more culturally loaded, a crouching lion with a human visage. They called it the Sphinx of Mars. In the grainy, early images, enthusiasts would trace bold lines around the pixelated shadows, outlining what they insisted was a distinct head, a set of paws, and a long, recumbent body, a mirror image of the Great Sphinx of Giza transposed onto the Red Desert. The comparison was electrifying, suggesting a cosmic connection between two worlds, a shared architectural language spoken by civilizations separated by millions of miles of empty space. It became a cornerstone of the broader Cydonia mythology, proof for believers that the face was not alone, that an entire complex of monuments lay waiting to be uncovered. The geological reality, however, is a lesson in selective perception. When you look at the raw, unmarked orbital photograph, you see a typical Martian butte, a towering mesa sculpted by eons of erosion. It is a chaotic jumble of cliffs, landslides, and deep shadows, a natural ruin. The so-called Sphinx shape only emerges when you ignore most of the actual geology and connect a few specific dark patches and light ridges with imaginary lines. It is a classic example of connecting the dots to draw the picture you want to see. The head is a sunlit plateau, the paws are debris fields, and the body is the elongated shape of the mesa itself. From any other angle or under different lighting, the illusion completely falls apart. This formation is not a carved monument, but a testament to the incredible power of non-living forces. The same winds and temperature shifts that created the face also crafted this butte, fracturing bedrock and carving valleys in a completely random natural process. The resemblance to an earthly sphinx is a staggering coincidence, a Rorschach test played out on a planetary scale. This secondary mystery highlights how one powerful illusion can birth an entire ecosystem of belief. Once the idea of an artificial complex in Cydonia took root, every subsequent strange shape in the area was viewed through that lens. A random hill became a pyramid, a collapsed ridge became a wall, and this complex mesa became a sphinx. It demonstrates a fundamental principle of exploration, the constant tension between what we hope to find and what is actually there. The Sphinx of Mars is a phantom, but its persistence in our cultural conversation reveals a deep and enduring truth that we are forever drawn to the idea of echoes, of finding our own history reflected in the silent stones of another world. The Martian surface is a canvas for our grandest speculations, and among the most persistent is the idea of colossal, crumbling architecture. From certain orbital perspectives, long, sinuous ridges snake across the landscape, their walls appearing strangely smooth and translucent in enhanced images. To some, these are not natural formations at all, but the shattered remains of vast glass tubes, perhaps once part of a planet-wide network of habitats or transport conduits for a vanished civilization. The visual suggestion is powerful, painting a picture of a Mars that was not just alive, but technologically advanced, its infrastructure now lying in ruins under the rusty sky. This theory taps directly into a classic science fiction aesthetic, the image of a domed or tubed city protecting its inhabitants from a hostile environment. It is a compelling narrative, but the geological explanations are far more grounded and, in their own way, just as fascinating. What appear to be glass tubes are almost certainly one of two very natural things. The first candidate is a lava tube. On both Earth and Mars, when a river of molten rock flows across the surface, the outer layer cools and solidifies first, forming a solid crust. The lava inside can continue to flow, eventually draining away and leaving behind a long, hollow tunnel. Over time, sections of the roof collapse, creating a chain of pits or a sinuous, trench-like depression. From above, the remaining arched sections of the tube roof can look like a rounded, tubular ridge. The second, and perhaps more common, explanation involves wind and sand. These features could be inverted channels or yardangs. On an ancient Mars with flowing water, river channels would have been filled with sediment. If that sediment became harder than the surrounding material, perhaps through mineral cementation, a strange reversal occurs. Later, when the wind scours the landscape for millions of years, it erodes the softer bedrock around the old channel, leaving the hardened riverbed standing high as a long, meandering ridge. It is not a tube, but a fossilized river cast in stone, a ghost of water that once flowed there. The apparent glass-like or metallic sheen in some images is a trick of processing and light. Raw orbital data is often contrast-stretched and color-enhanced to bring out subtle geological details for scientific study. This can make certain minerals or sun glints appear brilliantly reflective. Combine that with a low sun angle that casts long, sharp shadows inside these troughs, and the ridge can take on a startlingly artificial, structured appearance. Our minds, already primed by the tube-like shape, interpret the bright highlights as sunlight glinting off a smooth, transparent or metallic surface. It is a perfect storm of pareidolia on a landscape scale, where geology, photography, and human imagination collide to build a cathedral of speculation from the simple stones of Mars. Even the moons of Mars hold their own impossible geometry. Orbiting the red planet is a small, lumpy world called Phobos, a captured asteroid barely 17 miles across. Yet on its dusty, cratered surface, the high-rise camera aboard the Mars Reconnaissance Orbiter captured an anomaly that seemed to defy its chaotic surroundings. There, standing stark against the gray terrain, was a tall, slender shadow cast by a perfectly rectangular block. The media instantly dubbed it the Phobos monolith, a name evoking the mysterious alien slabs from the film 2001. It looked like a towering obelisk, a stark monument placed on this tiny moon. The reality, while less cinematic, is a dramatic story of cosmic violence. This is not a constructed slab, but a colossal boulder estimated to be about 90 feet tall. Its remarkably straight sides and sharp corners are likely the result of a cataclysmic event, the very impact that created the nearby Stickney crater, one of the largest features on Phobos. When a meteorite strikes a rocky body, it doesn't just make a hole, it shatters and fractures the surrounding bedrock along natural planes of weakness. The monolith is almost certainly a gigantic fragment that was blasted free but did not fully escape the moon's weak gravity. It now rests on the surface, a stark, geometric tombstone marking its own violent birth. Its rectangular shape is not a signature of design, but a testament to the way solid rock breaks under unimaginable stress, often cleaving along straight lines. This same principle of natural geometry repeats itself on Mars proper. From orbit, sharp-angled shadows sometimes stretch across the Martian plains, cast by boulders that have fractured from cliff faces in a process called thermal stress cracking. Mars experiences extreme temperature swings, hundreds of degrees between day and night. The rock expands in the daytime heat and contracts in the frigid dark. Over countless cycles, this relentless expansion and contraction creates weaknesses, and eventually the rock splits. It often fractures along its natural crystalline structure or existing fault lines, which can produce surprisingly clean, right-angled breaks. A boulder that shears off in this way can tumble to the base of a cliff and land with its freshly broken face pointing upward, casting a crisp, rectangular shadow that looks for all the world like a placed stone block. Our instinct to see intelligence in a right angle is powerful, born from a world we have built ourselves. But nature is a master mason, using the simple, relentless tools of impact, heat, cold, and gravity to quarry and shape stone on a planetary scale. The monoliths of Mars and its moons are not messages. They are natural sculptures reminding us that the universe needs no architect to create forms of breathtaking and often misleading precision. The debate over monoliths and fractured stone is rooted in geology, but some modern controversies venture into far more speculative territory. Among the most heated discussions in recent years are claims that we are not just seeing ancient fossils but present-day life. A handful of researchers have pointed to specific images from the rovers, arguing they show something astonishing: fungi growing on the Martian surface. The photographs in question often depict clusters of small, round, whitish patches dotting the soil, or sometimes puffball-like forms clinging to the sides of rocks. In one series of images taken over several Martian days, these objects appear to change slightly, with some seeming to grow or new ones appearing nearby. To the proponents of this theory, the visual evidence is compelling, resembling certain hardy lichens or fungal colonies found in Earth's most extreme deserts. They argue these could be resilient organisms, perhaps lying dormant for long periods and reactivating when conditions briefly become more favorable. The idea is electrifying, suggesting a Mars that is not a dead world, but one with a tenacious, if cryptic, biosphere clinging to existence right now. The mainstream scientific response is one of profound skepticism, grounded in a principle known as Chinese letter burden of proof. Making an extraordinary claim, especially one about extraterrestrial life, requires extraordinary evidence. The consensus view is that these peculiar white patches and spherical forms are almost certainly non-biological. The most likely candidates are mineral crusts, deposits of sulfate or chloride salts left behind as briny water evaporates from the soil. Another strong possibility is that they are more of the now familiar hematite concretions, similar to the blueberries but with a different surface texture or coating of dust. The apparent changes observed over time have simpler explanations as well. The Martian wind is constantly moving fine dust, which can partially cover or uncover small rocks from one day to the next, creating the illusion of growth or movement. A slight shift in the rover's camera angle or the sun's position can also dramatically alter shadows and highlights, making the same object look different. This has sparked a fierce and sometimes public debate, highlighting a fundamental tension in exploration. On one side is a drive to challenge established paradigms and interpret data with bold new hypotheses. On the other is the rigorous, cautious process of ruling out all possible abiotic explanations before ever invoking biology. Scientists know all too well how non-living chemistry can mimic life. The round white patches could be formed by a purely geological process called perchlorate deliquescence, where salts in the soil absorb tiny amounts of water vapor from the atmosphere, forming a temporary briny liquid that then recrystallizes into crusty blobs. The debate is not just about these specific images, it is about the very methodology of discovery. It underscores that on an alien world, the most Earth-like shapes might be the most deceptive, and that the greatest discovery in human history will not be announced because something looks like a mushroom, but because a suite of instruments tells a consistent, unambiguous story that no known geology can explain. High above the plains, the view from orbit reveals another layer of Martian strangeness. Vast stretches of the northern lowlands are etched with sprawling, geometric networks. From a distance, these patterns look unnervingly organized, like the ghostly footprints of cities. Enthusiasts tracing lines over these images point out what seem to be long, straight avenues, intersecting at right angles, and the crumbling outlines of massive, blocky foundations. It is a tantalizing vision, a bird's-eye view of a Martian metropolis frozen in time, its gridwork streets still visible from space. The raw, unaltered photographs do show something remarkable, a landscape fractured into countless polygons, often pentagons or hexagons, creating a global-scale honeycomb. But this is not urban planning, it is the signature of a planet breathing with the seasons. These are permafrost patterns, the direct result of water ice existing just below the surface. Mars experiences dramatic temperature swings. In the deep cold, the ground contracts, cracking open. In slightly warmer periods, it expands again. This relentless, seasonal flexing over thousands of years creates a network of fractures in the permanently frozen ground, much like the cracks that form in old mud. The polygons we see from space are the surface expression of this underground crack network, outlined by troughs where dust has collected or where frost preferentially forms. The straight lines and right angles emerge because the stress in the ground is often uniform, causing it to fracture along the most efficient geometric pathways. For a perfect earthly mirror, you need only look to the Arctic tundra. In places like Alaska or Siberia, identical polygonal patterns cover the ground, a phenomenon scientists call patterned ground. They form through the exact same process of seasonal freezing and thawing of permafrost. From a low-flying plane, these terrestrial landscapes look just as artificial, just as deliberately designed as their Martian counterparts. They are a beautiful, natural geometry. On Mars, the scale is often grander, and the absence of any vegetation makes the patterns appear even more stark and manufactured. So the ancient city grids are not ruins at all, but a living, albeit frozen, diary of the planet's climate. They tell us that vast reserves of water ice lie just beneath the dusty surface, and that Mars is still a dynamic world, its skin still cracking and shifting with the slow turn of its years, sketching phantom metropolises across its plains. The newest chapter of Martian mysteries is being written right now by the Perseverance rover, and its first strange finds have a distinctly familiar origin. Strewn across the rocky landscape of Jezero Crater are bizarre, shredded materials, snagged on stones or fluttering in the wind. In one image, a tangle of silver threads clings to a rock. In another, a strange foil-like sheet is caught in a crevice. They look like scraps of alien technology, the discarded packaging of some unknown visitor. The truth, confirmed by NASA engineers, is both mundane and profound. This is not alien tech, it is our own. The materials are debris from Perseverance's own dramatic arrival. That shredded mesh is likely Dacron, a synthetic fiber used as a thermal blanket on the rover's rocket-powered descent stage. The foil could be from the backshell or parachute. When the descent stage, its job done, flew off to crash a safe distance away, it likely scattered these lightweight fragments across the terrain, where the Martian wind then carried them like cosmic tumbleweeds. This creates a fascinating, almost humorous meta-mystery. Each new mission to Mars brings with it a fresh wave of strange sightings, and almost invariably, they turn out to be pieces of the very system that delivered us there. The Curiosity rover found its own heat shield fragment. Earlier missions left behind landers and defunct hardware. We are now in the era of finding our own archaeological layer on another planet. It is a powerful reminder that our exploration is not a passive observation. We are active participants leaving traces. Every shiny sliver or tangled web we puzzle over is a signature of human ingenuity, a tiny flag planted not in conquest but in the complex process of arrival. These finds force us to be better detectives, to distinguish between the signals we send and the signals we hope to receive from Mars itself. They are the price of admission to an alien world, our own litter on the frontier, reminding us that the greatest mysteries may not always be about what we find, but about what we bring with us and what we leave behind. That tiny, perfect doorway carved into the cliff is the ultimate symbol of our Martian quest. It is a shape that screams intention, a structure that demands a story. Yet, as we have seen 30 times over, that story is almost never the one our human minds first imagine. These visual mysteries, from faces and crabs to bones and pyramids, share a common origin. They are born from the powerful dance between a truly alien geology and the deeply human need to find meaning in the unknown. Pareidolia is our constant companion, the instinct that paints a crab in a shadow and a face on a mesa. The relentless Martian wind is the master sculptor, patiently carving spoons and pyramids from solid rock over millions of years. Ancient water, now vanished, left behind a chemical legacy of perfect spheres and crystalline flowers through slow mineral deposition. And now we find our own artifacts, the shiny debris of our own ambition, scattered among the stones. The greatest trick Mars plays is making its natural history look so hauntingly like our own. But this is where the real wonder begins. When we look past the phantom doors and imagined statues, we are left with something far more staggering. The true strangeness of Mars is not in the illusions of a populated world, but in the hard, geological evidence of a lost one. Those rounded river stones, the dragon-scaled terrain, the mineral flowers, and the layers of sedimentary rock, they all tell a coherent, profound story. Mars was once a world of persistent rivers, deep lakes, a thicker atmosphere, and a complex, dynamic climate. It was a world that, for a long stretch of its history, was habitable. The real and enduring mystery is no longer whether we see familiar shapes in the rocks. The ultimate question, the one every one of these 30 strange finds points toward, is what happened to that blue world, and in its ancient, wet silence, did life ever find a way to begin? The journey through these 30 strange discoveries reveals a world of profound duality. Mars is both a planet of breathtaking natural wonder, sculpted by ancient water and relentless wind, and a vast, silent canvas onto which we cannot help but project our deepest hopes and fears. Every face, fossil, and floating spoon was a testament to this beautiful tension between what is there and what we wish to see. We have walked with ghosts in the dust only to find the sculptor was always the wind, the chemistry, or the simple, stubborn geometry of fracturing stone. Yet the solving of each mystery is never an ending. It is the beginning of a deeper, more profound question. Why does this rock have such a strange chemistry? What does that gas spike truly mean? Each solved illusion peels back a layer, driving our robotic geologists to dig deeper, to sniff the air more carefully, to seek the next clue. This relentless curiosity, sparked by a grainy image of a face or a shiny rock that looks like metal, is what fuels our greatest explorations. It binds the public's wonder to the scientists' meticulous work, creating a shared story of discovery that spans the globe. And that story is rushing toward its most thrilling chapter. The next great leap is already underway. Rovers like Perseverance are now caching carefully selected tubes of rock and soil, the most promising samples from an ancient lake bed. These precious cores are being laid down like a treasure map waiting for the future. The goal is a Mars sample return mission, an interplanetary relay race to bring pieces of another world back to Earth. In our most advanced labs, freed from the constraints of a rover's tiny instruments, we could analyze those samples for the subtlest traces of past life, for chemical signatures no robot could ever detect. The ultimate mystery, the one whispered by every rounded pebble and mineral flower, may finally be answered not by a camera from a distance but by a rock in our hands. So, as our robotic eyes continue to scan those alien plains, what was your favorite strange find on this journey? Was it the lonely doorway, the ghostly spoon, or the blueberries that proved a wetter world? Share your thoughts below, and if you enjoyed this voyage through Martian mysteries, a like and subscribe helps bring more explorations your way. The Red Planet is not done with its surprises, and neither are we. Stay curious.